Okay, so we were just saying that we have a vibration that is transferred into the cochlea. And we had said the vibration, because of the movements of the stapes into and out of the oval window, it's going to transfer this vibration into the fluids in the scala vestibuli and the scala tympani. And you're going, depending on the frequency of the vibration, you're going to get a portion of the cochlear duct is going to be vibrating. Now, what is the cochlear duct made up of? It's made up of two membranes and stereocilia. On the bottom, we have a very flexible membrane called the basilar membrane. It's flexible. So when the vibration is introduced, it vibrates along with the vibration. Attached to it, we have the stereocilia, and that's these little blue things standing up that I've drawn here. And we had said these are the mechanical receptors. Now, what happens when they bend, they're going to send a signal to your brain. So we have a vibration in a very specific location in the cochlea based on the frequency of the sound, and the basilar membrane starts to vibrate and it bumps into a very stiff membrane that's just above it. Both of these, the basilar membrane and the tectoral membrane, that is what is represented by the cochlear duct itself. So this black line that I've drawn here is both of these. All of this material up here is the cochlear duct. So we have stereocilia in there that are bent. Now, how does bending a stereocilia send a signal to your brain? Well, it ends up that these stereocilia are connected together by something called a tip link. And it's a connection from one stereocilia to another one. And what is it connected to? So what it's connected to is a little door. It's a non-specific ion channel that can be opened when the hairs move. So when this hair moves, when this stereocilia is bent, it pulls on the door that is closing this non-specific ion channel. It opens it up. Now, what is in the fluid? The fluid within the cochlear duct, a lot of potassium ions. So remember, positive ions depolarize. So when you introduce positive ions into the stereocilia, it causes the nerves that are connected to them to send a signal to your brain saying, "Ah, I hear high C," or low D, whatever frequency it happens to be. And that's how you hear. So we finished hearing. All we have left is equilibrium. That's next.